Hey, welcome back to the Wolfram Tech Conference 2018. If you haven't tuned in before, I'm Jesse, and I'm here talking with various developers and other interesting people who are using Wolfram technology in really cool ways. I'm here with Tom Wickham-Jones. Can you tell us a little bit about what you do here at Wolfram, maybe how long you've been here and what you're talking about here at the conference specifically?
Yeah, sure, fine. So I've been with the company kind of a long time, almost since the very beginning. Not the beginning, but I joined a couple of years after it started, so in like 1990, and I've been working on various aspects of the Wolfram engine, the main core computational part of the the things that's at the center of the Wolfram technology. I am particularly interested in computer languages and implementation of computer languages, and I've worked on many different projects, evolving the language and trying to look at ideas from other places and see what role they have, why they're useful, what benefits they might have, and seeing what role they have in our technologies. One of the core things that involves is the notion of code compilation. So compilation of code means, if you look in Wikipedia, it says, which is source of all knowledge.
No, don't go to Wikipedia. Just keep watching.
Oh, don't go there. But it says, it would say a compiler is a system for translating one form of a language into another language. Quite often you'd use a compiler to turn a high-level form of a language into a much lower-level language that's closer to the way that actual hardware works, so that it can execute faster. But there's many other, interests and benefits that you can get from compilation technology. So I've worked. Wolfram Languages had a compiler for many, many years. In the last few years, we've been working on a totally new version of the compiler, a total rebuild, starting from scratch using the latest knowledge and advances in languages to build a whole new compiler technology. And we've been working on this for about 3 years, and at conferences like this I've been showing people previews of where the technology is going. But this year is different because we're actually including the first initial version of the new compiler is being included in the upcoming version 12. I think I'm allowed to say version 12, everyone else is saying it. Anyway, so and that's pretty exciting. As a software developer, it's kind of cool because you work on things for a long time, but the time when you feel really creative is when the fruit of your labor gets included in an actual release, and people start using it. And then usually what you find is they're using it in all sorts of ways that you never imagined, because you have your way of thinking about things, but
Right, yeah.
everybody has different, and so that's pretty exciting. It's also neat because it started out with just me and one other developer that working together, but we've built up a big team, and quite a lot of our team we've been giving different talks about different aspects of the compiler at the conference. So I think that's what I've been doing for the past few years.
Cool. So other members of the team, what sort of talks are they giving here at the
Well,
conference?
they're using the technology. Compiler. The focus on the compiler is to make programming efficient and leverage new ways of reaching new types of programs that have been maybe a bit harder to write, or reaching down to sort of machine hardware or special, maybe even exotic hardware, things like GPUs and such like. And our compiler technology is an interesting way to sort of access things like that. So people are showing that it's coding. So not everybody wants to do coding, but quite a lot of people do as well, and that's what's kind of interesting.
So it's a component of the language. I know. Is it the compile function? Has it just been sort of updated now?
Well, it's a whole new technology that comes out with it. So it uses an underlying compiler tools that are used for more traditional languages, something called LLVM, and that's kind of so we do sort of processing on the code, and then we translate into the LLVM representation, and that's very beneficial because there's lots of things that support LLVM, and then we can leverage those technologies to translate out and get fast, efficient, sort of executables for a wide variety of different sort of hardwares, including all the platforms that we want to run Wolfram technology on. So and other platforms that we don't. So it has a lot of potential for moving things forward and reaching new areas of computation. So,
So you mentioned that, I mean, you're excited to see users kind of take this and sort of their own, and make it their own sort of deal. So what are some potential applications that you would hope that users would want to use?
I mean, I think this is there's a variety of different things that it can do. I think people that just want to do large-scale computation, high-performance computation, and there's a lot of people in the users that they do interesting computations, but they just want to take it sort of further and utilizing more aspects, multi-core. Just access that people haven't really had before. Another aspect that's kind of interesting is people inside the company can build features on top of our compiler technology, and there's lots of opportunities for that. For example, one area that's kind of interesting is the machine learning and the neural network functionality that we have.
Right.
And I've been working with them. They're pretty excited to start incorporating some of the technologies that we're that our compiler can do. And in essence, just trying to put a simple statement on this, the code that we're when code is processed with our compiler, we're taking Wolfram language code, and it can execute as fast as in more traditional C or C++ code, because it's using the same suite of technologies, and that's we're pretty interested. That's pretty exciting, but you get a lot of the benefits of the sort of high level Wolfram language representation. So it's kind of a win in both ways. You don't have to work at some very low level, but you're not paying penalty for not going down there. So that's good.
Yeah. So do you see the Wolfram compiler technology being used to push code into production type settings?
Oh, very much so. Another interesting aspect of it is being able to make standalone applications that can execute. So you could develop something in the Wolfram infrastructure, but generate a standalone library or something, or a standalone application that could execute, without having to, it's a more deployable thing. It doesn't need a big engine that's sort of sitting there to execute. So yeah, there's lots of opportunities like that. So
Cool. I'm looking at the questions that I wrote. I think you've gone through all of them and sort of beyond. Do you have anything else that you want to share with users about the Wolfram compiler technology?
Right. Well, that's an interesting question. So, I mean, I think I've sort of run through the things. I think it has it's a way of sort of introducing languages evolve over time rapidly, and the languages that people are interested in now might not have existed a few years ago. And I think our compiler technology is also very new, interesting. So I think people are interested in languages. I think it's worth taking a look at what we're putting together. It has lots of interesting features. So compiler technologies, compiler theory, it's a big part of computer science. A lot of computer science departments, not all of, they devote their time to projects based around compilers. And what we've been working on is it's a nice open infrastructure. It's entirely implemented in the Wolfram language, which has been kind of an interesting exercise in itself to build something really big in our own language. Of course, now what we're working on is, since we have a compiler, we're working on trying to compile our compiler. So that's a typical thing that compilers, that,
Yeah, this table is
sorry, the table's fighting away, and that's kind of a thing. One interesting aspect of the compiler that we've worked on is that it supports. So it has static typing. This might be a bit technical for some people, but I apologise.
Well, it is a tech.
No, well,
talk,
that's fine. So we have a nice type inferencing system that we've developed. We put a lot of work into our type inferencing system, and this is using very much the sort of latest knowledge and sort of state-of-the-art inferencing technologies. They're important because you don't need to put, in old typed languages, you had to put type markup everywhere in your program, and it was just very cumbersome, and if you changed one thing, and it was an impediment, because if you wanted to change your program, you had to go and change lots of things. With type inferencing, you just need to mark up a few places, typically the input to a function, and then everything else can be it gets figured out by the inferencing engine, which is kind of interesting. It also supports a style of programming that's quite gaining popularity. Well, it's been popular for a long time, but and that's what's known as, so it's polymorphism. So you have one version of the program works in many different ways,
right.
But we support a version, it's called parametric polymorphism, where you give type parameters, and then the value of that is that one bit of code gets used in many different places. So you don't need to write a lot of code, but you get all the benefits of type inferencing. So
is that sort of the same? I mean, I know with Wolfram language functions, generally you can overload a function with different, like if it's an integer, it'll evaluate in one way.
Yes, but that's more a sort of runtime type of thing. This is doing it at some sort of ahead of time. This is doing some analysis of the program before it starts executing. And so it's able to find inconsistencies and problems and verifications at some sort of analysis phase. There are pros and cons to that. Some things are not decidable, or it can be some people that program, they like the very free form aspect, just throw things together and get a result coming up. On the other hand, sometimes it's good when you're starting to build some production code, you want a little bit more assistance, and you might want it to some of the benefits of sort of fast execution. But yes, there is some sort of analogies with the general sort of Wolfram system. So.
So I guess just one other question that I thought of. 10 years from now, where do you see Wolfram compiler technology going and sort of changing?
That's an interesting question. We've got a huge suite of plans and projects and things that we want to work on. It has a tremendous capacity. We've just made an initial version with a few functions that people can execute and start to use. But I think it has a lot of potential for for users writing new styles of programs and it's experimenting like that. It has a lot to offer the Wolfram system itself, so we can go back into the Wolfram engine, existing features, and we can re-engineer and re-implement things in new, faster, more efficient sorts of ways than we've been able to in previously. And I think that's going to be really interesting. So I think we've got plenty of work to do. So that's
Cool. Well, thanks for talking with me, Tom.
Great.
And if you stick around later after a short break, we're going to talk with some more developers and other cool people. So thanks for joining.
Okay, cheers everyone.